is the only good result from the probability theory or statistics. Statistics or probability theory, this science has been dead or no progress for the past 100 years. So not compared to other sciences. Mathematics, there are many other new advances, not very much advances. Include those without advances, including probability theory or statistics. That means they will say, if x1 normal, and they are linear add together, then conclusion that z also normal. Now, then what about another case? Let's say x2 squared plus x1 squared, x1 squared equal to z. That means normals square plus together, then what about distribution of z? There's a no answer. Because this is nonlinear. That means any nonlinear result, no result. They say you do not know anything. That is the achievement of probability theory. So that means only normal and linear you can easily handle. Because normal is easy to handle. Anything others difficult. For example, so this one I'll just show you this picture. So this one is some of the example. Because I have this kind of concern, I searched the internet. I found that another professor also have similar concerns. So he even used graphical way to illustrate. For example, if x follows normal distribution, nice and beautiful. Yeah. This is x. Then what about sine x? Sine x distribution is this one. Beyond simple expression. It's not normal at all. So similar to here. Normal, squared, like similar to this one. X is normal. So sine normal result is this one. Beyond simple expression. So this is the problem. That means in our course we will heavily use the theory of statistics or probability. But this subject gives us very little support. So I will tell you, if they give us better results, our course workload will be maybe only half. We finish the job much earlier. Because they do not support us very much, so we have many other difficulties. I will tell you gradually. So this is about statistical theory results. So we have this picture to show it. But in the real world, we have many examples of assembly. For example, a pin and a hole, a cylinder and a hole. This a set, as well as piston and cylinder. We have a cylinder, piston in the cylinder, and an engine. So also have a pair, as well as a hard disk. We already explained. We have many kinds of designs. All this individual normal. But the result, if the result is linear, if we have this linear model, it's easy to handle. Otherwise, we have great difficulty. For example, here, so this y is equal to x2 minus x1. So this is assembly equation. And so if x2 normal, x1 normal, and they are linear, then ys will be normal. However, here W means there is a distribution, statistical distribution. So this distribution result is available under three conditions. First one, all these must be normal. X2 we must know it, X1 we must know it. Second, all of them must be normal, or we call a Gaussian distribution. This is here, the first one. But in the statistical theory, there will be many other kind of distribution. For example, uniform distribution, T distribution. We already introduced chi-square distribution. There are many other kind of distribution. That means here we have so many, but only one case we can solve. Any other simple solution. And also they must be linear. Fortunately, this is linear, but once we go to QD, it's not linear. So that means, and to get this result, how much, that means in order to know how much is YS, it's not easy. It's not easy. Then you may say, oh, it's actually very easy. It's something minus something, right? So x2 minus x1 is very easy, right? But we must pay attention. If x2 is a single value, x1 is single value, then even primary students can solve this problem. But however, we have this trouble. Ys equal to x2 minus x1. This x2 is following a particular distribution. X1 following a particular distribution. Then what will be the result of this one? We don't know. So that is the difficulty. It's not simply 10 minus 10. 10 minus 10, anybody can solve it. Just 0. But our case that x2 follow normal a distribution. This one follow distribution. It is in a range. They are in a range. So this means a range minus another range, what would be the result? That is the difficult part. That is difficult. That's the precision analysis problem. Very difficult to solve. That means we do not have the theoretical support. We do not have the theoretical support. So here we'd like to mention the difficulty in getting the theoretical support. Otherwise, our course will be much simpler. So the difficulty is that if we have something unknown, for example, only x2 we know, x1 we don't know its distribution, then no way to solve. Or we know all of them, but they are not normal distribution or Gaussian distribution. That means only they are not this one. For example, if they are normal, or if they are chi-square, or if they are T distribution, then we will be in trouble. And also they must be linear. So there are so many limitations. Because this one, so we do not know this result. Why it is so? Because there is a statistical theoretical limitation. No progress from statistics theory over the past many years. So we know engineering advances almost year by year, like a precision. Every 20 years, we increase 10 times. For IC industry, the computer performance doubled every 2 or 3 years. The hard disk capacity doubled 2 or 3 years. But this theory is still there. Medicine cannot answer. So, how people solve it in the past? That means, although we have so many difficulties, how do we solve it? For practical solution. Actually, people solve it through computing technology, or the Monte Carlo approach. That means they use a random number to generate random number to follow normal distribution to simulate x2. They use another random number generator to generate a number to simulate x1. Then you got a number. Then two numbers minus each other, then you got an answer. Then you collect many data. Then you try to figure out how it looks like. So this is the technique solved in the past. But it's very troublesome. you need a long-time computing. So nowadays computer is very fast. So we can solve it in an easier way. But in the old days, computer very slow, or even no computer. So using this technique will take a long time, not practical. Not practical. So this is the difficulty. That means such a simple design, even we feel some theoretical difficulty. We just use this one to reduce the difficulty. So it is because this reason that means although we define the problem, so the problem solution looks very simple. But we find if we try to solve the problem, we have some theoretical problem. So if we want to have better solution, we need to redefine the problem. Use another way to solve this problem. This problem is very practical. For example, we call the worst case model. Worst case model is a practical solution. So what is the meaning that we agree perfect solution not available because of theoretical limitation. We will have some back-down solution, which is called worst case model. Of course, we have another one called statistical model. Therefore, in our course, we always have two solutions. But we need to pay attention. These two solutions is a practical solution out of no solution. There is no theoretical support for this one. For the details, let's continue next Tuesday. See you then.